She read a number multiplied by another number to get a product. So yesterday when I asked you what the factors, Amani, of 24 were on your quiz, we want to think of all the factors. So we always start with 1 in that number, right? And then we would say 2 and 12 and 3 and 8 and 4 and 6. Cool? Awesome. So we actually got through quite a bit. Let's look at some prime factorization today. This is a little bit different on page, this is page 2. So we're kind of going back a little bit. We practice listing factors, but this is page 2 in your packet. Are we okay? Can we do this? All right. So first of all, what is a prime number? My dudes. I see one hand. No one should be talking. I see one hand. Yes, Peyton. Vinny. Yes, so there are no factors for this number other than that number and 1. All right, so when we're thinking of prime factorization, we're kind of listing the factors, the smallest factors of it. Okay, so when I say prime factorization, oh my gosh, why do we have properties right here? This is a product of prime numbers. So we're going to multiply these prime numbers to get whatever our product is. A product of prime numbers. I need an S, sorry. All right, Vinny, you need to go because this is now at least the 3rd time. Go ahead and put your water bottles up there on the table so we're not being distracted every 2 seconds by them. All right. So here's how we're going to write the prime factors. What two numbers could, guys, what two numbers could I multiply to make 56? Big numbers. Vinny, I'm going to ask you to go to the ozone, which will come with a referral and a phone call home. This is the 4th time I'm speaking to you specifically. Not okay. Get on page 2 with us and cut it out, please, and thank you. 4 and 14 we could do. Want to do that? So if we do 4 and 14, what two numbers multiply to make 4? 2 and 2. Very good. See how I'm kind of making a little tree here? And what two factors make 14?
7 and 7.
No. 7 and 2. So if I were writing this out, I would say 2 times 2 times 2 times 7. If I multiply these all together, we would get 56. Josh, are you with me? Thank you. We can simplify this though. Have you seen exponents before? If we have a factor of 2, how many times do we have that factor of 2? 1, 2, 3 times. So if we have it 3 times, our exponent is 3. So we could rewrite that as 2 to the 3rd power. That tells us how many factors we are. Is this saying 2 times 3 is 6? No, it is 2 times 2 times 2, which is not 6. Josh. Thank you. All right. So that wasn't so bad. What about 75? Yesterday I told you to think about quarters maybe, or maybe I was telling my seventh graders that. How many quarters are in 75 cents? 3/4. And how much is a quarter worth? 25. So would you say that 3 times 25 does make 75? Yes. But 25 is not prime, so we have to keep going. What two numbers can I multiply to make 25? 5. And 5 times what? Thank you. 5 times 5 is 25. So now this looks very similar. We're going to use our smallest number first. How many factors of 3 do we have? Just one, right? And then this is times 5. But how many factors of 5 do I have? 2. So I'm going to write that as the exponent. Do you see how this is like 3 times 5 times 5? If I multiply those all together, I would get 75. Those are the prime numbers I would multiply together to get them. This prime factorization helps us get greatest common factors, and you're going to see that soon, okay? So doing this and knowing how to do this is pretty helpful, okay? So let's try 180. If it ends in 0, what do we know it's divisible by? 10. So let's start with 10. 10's a nice number. And it makes this number, right? 10 times what is 180? You can say it. 18. 18. 10 times 18. 10 times 18 is 180, my friend. What? 180. Excuse me if I misspoke, but you can read the board. You don't have to argue with everything that comes out of my mouth, James. It's getting a little old, my friend. What two numbers can I multiply to make 10? Peyton? 5 and 2. So I'm going to put it as 2 and 5. It doesn't matter. What two numbers can I multiply to make 18? Not 2 and 7. 2 and 9. Okay. So 2 is prime, 5 is prime, 2 is prime. What about 9? 9 is not prime. Not 6. What, Peyton? What? 2 times 3 is 6, but this is a 9 that we're trying to make. 3 times 3. Thank you. All right. Guys, if this extra step helps you, don't forget if it's on my paper, it should be on yours. If this extra step helps you, write it out. 2 times 2 times 3 times 3 times 5. So how many factors of 2 do I have? 2. So I write 2 to the second power. How many factors of 3 do I have? 2. So 3 to the second power. And it's being multiplied just by that 5. So if I multiplied these prime numbers together, I would get 180. Okay? Okay. All right. 48. Think of two numbers. What can we use? 8 and 6? I'll take it. 9 won't work. It does not add up to 9. All right. Is 6 prime? No. What two numbers can we multiply to make 6? Good. So 2 times 3 is 6. Good. 2 and 4 here. So prime is 4 prime? No. So 2 and 2 here. So here, how many factors of 2, guys? 1, 2, 3, 4 factors of 2. And don't forget we're multiplying it by 3 to to get 48. Have you guys done something like this before? Maybe, maybe not. All right, this is a really big number. But I know it's divisible by 3 and 9 because it adds up to 9. Right? Which also means it's divisible by 6. So what do you want to do? 9? All right. So 9 into 702. This is going to take a second. Think through this. Try and think through this long division, please. Take a second. Center yourselves. Some of you need to take a deep breath and chill right now. The first question we're asking, can 9 go into 7? No. Can 9 go into 70? How many times? 7 times is 63, right? What's 70 minus 63? 7. And then I bring down the 2. How many times can 9 go into 72? Vincent, come sit over here. My gosh, man. I'm trying to help you be successful. How many times can 9 go into 72? 8. Good. And that's even. So this is a 78. Is 9 prime? No, 9 is not prime. 3 times 3, very good. Guys, the first thing I notice about, 78 is that it's definitely divisible by what? 2, because it's even. So if I'm thinking 2 into 78, 6 is what? 3? 6 and 13. Oh, I see, because you're using your multiplication table. That's a good idea. So this is 6. And this is 18, so this is 6. All right, so this is 36. 36 is definitely not prime, right? 9 and what? 9 times what? 9 times 4, yep. So this is 3 and 3, just like this was. And this is what? 2 and 2? So how many factors of 2? Count them. 1, 2, 3. Times how many? Good. 4 3s, Josh. Well done. My exponent. So 2 times 2 times 2 times 3 times 3 times 3 times 3. And here's an even bigger one. But I know since it ends in 0, we can do it by 10, right? We're just going to do 245 over here. What are 2 factors of 10? 2 times what? 2 times 4. Very good. All right. I know we can take a 5 out of here. So I might need to do a little long division, but we can do it. How many times? 6th graders. How many times can 5 go into 24? 4, good. 4 times 5 is 20. That's as close as we can get without going over. And then how many times can 5 go into 45? 9. 5 times 49. Is 49 prime? What's your numbers? Use your multiplication table if you have to. It's actually a square. So we multiply the number by itself. We multiply this number by itself. Yes, 7 times 7 is 49. Hey guys, if you didn't know that, Corbin, if you need to, you can leave. We're not fooling around anymore. We have one factor of 2. 5 times 5 gives us 2 factors of 5. And 7 times 7 gives us 2 factors of 7. Woo! All right. So that is prime factorization. That's a little different, right? But is it doable? I think so, especially with some of these smaller numbers. Some of these bigger numbers get tricky, but remember, start with the easy ones, right? Can we divide it by 2? Can we divide it by 10? Start with something that you know, and you might have to do a little long division, but you can do it. So let's write this out. Does this mean 3 times 4? It does, but does this mean 3 times 4? No, it does not mean 3 times 4. It means how many factors of 3 do I have? It means I have 4 factors of 3, and then I'm going to multiply that by 17. So here is how I would do that. Amani, get over it. What's 3 times 3? 9. Would you say 3 times 3 is also 9? Yes. Times this 17. Yes, good. 9 times 9 is 81. And then I have to say 81 times 17. Go ahead and take a minute to do that. 81 times 17. We're trying to find this composite number represented by those prime factors. 81 times 17. Our mouse shouldn't be moving. Our pencil should be. We haven't even done what we've done. Come on. Let's go. So multiply by 7, right? 56. Don't get confused by this 2 over here, the page number, sorry. Is that what you guys got? Check my work, because I've been known to get it wrong before, right, Jake? I'm human, people make mistakes. What's a mistake? It means mistakes allow thinking to happen, right? All right. How many factors of 2 do I have? 2. How many factors of 11? 2. How many factors of 13? Just 1. So what is 2 times 2? Come on, guys, we know this. 4. What is 11 times 11? Do you need your multiplication table? 1, 2, 1. All right, what is, guys? What's 4 times 13? 52. So if 4 times 13 equals 52, then we have 121 times 52. Landon, Zippy, your lippy, my gracious. All right, so 2 121s would be 242. 50 121s would be 1,000. is that 6,050? So 60 to 92 would be our composite number. Good thing you guys have been practicing your multiplication. Right? If we're not fluent in our basic facts, we gotta be practicing those at home for sure. Okay, here is page 3 that we've already started. Yes, we did. All right. A perfect square. Guys, what does it mean to be a perfect square? When we multiply that number by itself. So no. Oh, that has a factor that is a perfect square. Oh, we're gonna just not worry about perfect squares. All right. Hey guys, this is like our dance class being separated into groups. We're gonna divide candy up evenly, but we have 84, so we have to think of the factors. She does not want to make more than 20 bags, but has at least 3 friends. So if she has 3 friends that she wants to give candy to, how many pieces would they get? 3 times what gives me 84? So I'm saying 3 into 84. It goes into 8 twice. That's 6 times. And it goes into 24 8 times. So this would be 28 pieces for 3 friends. Can 4 go into 84? Yes, you should look at that number and know. 8 and a 4, you can divide that evenly. 21 pieces here. If it's even and divisible by 3, we know it's divisible by 6. You can use your multiplication table for this one. How many times does 6 go into 84? 14 times. Notice these are going down by what? 7, 7. Interesting. 7 pieces. How many? I'm sorry, 7 friends. How many pieces? 7 times 7 is not 80. 7 times 12, right? Is 84. All right. So 8. Does 8 go into that evenly? No. Does 9? No. Does 10? No. Does 11? No. Does 12? Yes. So 12 friends could each get 7 pieces. And 14 friends could get how many pieces? 6 pieces, right? She said she doesn't want to make more than 20 bags, so we wouldn't go any further. So we have to think of the factors, and in this case, they're making us have a range between 3 friends and 20 friends, because she doesn't want to make more than 20 bags. All right. Here, a great way to figure out if these are prime or composite is to just write out their prime factorization. So this is composite, right? What about 125? It's composite for sure. 5 quarters would be $1.25. I'm just having fun making prime factorization trees. What about 151? I'm gonna look at my multiplication table. Do you guys see 151 anywhere? I see 152, 153, watch your language. I think it's prime. Let me know if you guys find something. How about 67? Do you guys see 67 on your multiplication table anywhere? I see 68, 65. I do not see 67 though, so I think that's prime. This is definitely divisible by 3, so this is a composite number. 29, I think, is prime. Nothing I can think of. 51 is not prime. I think you'll find 51 here. Yes, it's a 3. It's divisible by 3, right? Because it adds up to 6. What about 233? I don't know what I would divide it by. It's not divisible by 3. It's not divisible by 4, 5, 6. Is it divisible by 7? I don't think it's divisible by 7. It's not divisible by 9, so I'm saying this one's prime. 177, this should be on our board if it is anywhere. I'm gonna say it's prime. Oh wait, no, it's not prime. 7 plus 7 is what? 14 plus 1 is 15. 1 plus 5 is 6. So it's definitely divisible by 3. So we got to use those divisibility rules for sure. All right, we have done page 3. We are going to finish up page 4 today. Hey guys, this is where you're going to get a chance to practice the prime factorization. Landon, no more problems. Seriously, do you need to go sit by yourself? All right, remember prime factorization. I will do 2 of these. Raise your hand and tell me which 2 you want me to do. Amani. Notice I asked you to raise your hand and let me know. Amani is picking a number. 22. All right. 23. What else, Vinny? 20. And 20. Okay. So if I can't think of anything and I see that it's even, the first thing I'm going to do is take out a factor of 2. Okay? So 2 goes into 968. Guys, the extra noises and the extra talking really need to stop today. 2 goes into 9 how many times? 4 times 2 is 8, right? Now I have a 16. This is 8 times. And that goes away. So 2 into 8 is 4 times. Ooh, that didn't get us too much closer. But this is a nicer number, right? What if we take 4 out of this? 1, 2, 1. Do you see where I'm getting that? 4 divided by 4 is 1. 8 divided by 4 is 2. 4 divided by 4 is 1. This 4 is not prime though, so make sure you split that into 2 2s. 121. I am consulting here. 121 is divisible by 11, and that is a square, so 11 times 11. So now that I've made my factor tree, I'm going to write all of these down. So I'm thinking 2 times 2 times 2 times 11 times 11. Simplified, remember, we can use our exponents. How many factors of 2 do I have, Corbin? 3. So I'm going to put my 3 as my exponent. Good. And then how many factors of 11 do I have, Josh? 1, 2, or 1, 2. Well, don't count all of them. Pay attention, and then you'll know what you're counting. All right. Same thing here, but I notice 16 and 32 are divisible by 4, and by 8. So I might jump to take an 8 out of here. If I take an 8 out of here, 8 goes into 16 4 times. Then it would go into 3 0 times, and 32. Oh my gosh, what did I do? Not 4 times. 8 times 2 is 16. So this would be 204. Is 8 prime? James, is 8 prime? James, is 8 prime? Is 8 prime? Is 8 prime? No, no, it's not prime. So 2 times 4, right? And that 4 is still not prime. If I take a 4 out of here, it is 51, right? 4 goes into 25 times. 4 goes into 4 1 time. So this 4 is 2 2s. What about 51? This is 3 and follow your 3 until you get to 14, 17. 17 is prime though. So how many factors of 2 do I have? Avery in the back. How many factors of 2 do I have? Good. 1, 2, 3, 4, 5. So I'm going to say 2 to the 5th power and then times 3 times 17. All right. Remember to write out these things so you are multiplying all of these numbers together to get the composite numbers. Okay? So you have 18, 19, 21, 22, 24, and 25 to do. When you get done, you may put your packet up on this yellow folder, and then you should be working in Alex. Super important that you stay focused and get this done. Your voice should be between a 0 and 1. If you're out of your seat, I'm assuming you're putting your packet away and then going right back to your seat without bothering people. Right? 0 and 1. There may be whispering, nothing else. Please work and stay focused.